Hello guys, it is the second class of chemical kinetics. So let's start our class. So in this class we will discuss about rate of reactions and type of reactions. How many type of reactions are there? So there are different ways to express the rate of reactions. There are two type of rate of reactions. First one is average rate of reaction and second one is instantaneous rate of reaction. What is the average rate of reaction? Actually, average rate of reaction means it is the rate of reaction between two time points. And instantaneous rate of reaction, it is the rate of reaction at a particular time point. So let's an example. Suppose a student take 20 minutes to reach school by car. The distance between home to school is 10 kilometer. Find the average speed of the car. Average speed of car. So average speed of car we can calculate by distance by time. So what is the distance? Distance is 10 kilometer and time is 20. So 10 by 20. So your answer will be 0.5 kilometer per minute. But that is actually an average. It is an average rate, correct? Average speed. So the average speed always remain constant. Now suppose there is a red signal at 8th minute. At 8th minute there is a red signal. There is instantaneous rate or speed, distance upon time. So time is 8 minutes but distance is 0. That's why we can say instantaneous rate change from time to time. You can understand what is the meaning of instantaneous rate. Instantaneous rate is a rate at a particular time point. Suppose you move from your home and after 5 minutes, just exactly after 5 minutes, if you want to check the speed of your car exact at that time point, so that speed is called as instantaneous speed. Instantaneous speed of car you can calculate by speedometer which is fitted in your car. So that is, if your needle of speedometer show the speed, that speed is called as instantaneous speed. So average rate of reaction means rate of chemical reaction in appreciable smallest interval of time is called average rate of reaction. 1 mole of reactant produce 1 mole of product. If R1 and P1 are the concentration of R and P respectively at the time T1 and R2 and P2 are the concentration of R and P respectively at time T2. So average rate of reaction means rate of disappearance of R. So that will be equal to decrease in the concentration of R divided by time taken. So decrease in the concentration, decrement, due to decrement we have to take the sign minus, negative sign, and change in concentration of R means reactant divided by change in time. So that will be equal to R2 minus R1 divided by T2 minus T1. So negative sign indicate just decrease in the concentration of reactants. Now average rate of reaction means rate of appearance of product, because average or any rate of reaction we can have any rate of reaction we can explain in the form of reactant as well as in the form of product. So if we want to explain the rate of reaction in the form of product, then we can write down rate of appearance of product means it is increase in the concentration of product because divided by time taken. So increase in the concentration, due to increase we have to take the sign of positive. So increase in the concentration of product means delta P divided by delta T. That will be equal to P2 minus P1 by T2 minus T1. We have to always remember that rate of any reaction is same if we calculate either in any terms of reactant or product. In reactant or product both terms the rate of reaction always same. So positive sign indicates the increase in concentration of product. Now graphical representation. Concentration of reactant we have to put on y-axis and time taken we have to put on x-axis. Now reactant, actually we can observe that in any reaction reactant goes to decrease due with time. So At zero time, the concentration of reactant R naught, that is the maximum concentration. As time will pass, then concentration of reactant will obviously decrease. So at T1 time, concentration is R1. At T2 time, concentration will be R2. If we match these points, we will get a graph like that. So that is the graphical representation. And how can we calculate the average rate? Average rate, that will be equal to change in the concentration of reactant, means minus delta R, minus means that is a decrement in the concentration of reactant, divided by delta T. So that will be equal to R2 minus R1 upon T2 minus T1. Minus sign we have to put, that minus sign we have to put, because concentration of reactant decrease with time. Now if we are drawing the graph of concentration of product with time, so we know the concentration of product increase with time. That's why if concentration of product is P1 at time T1, and at time T2 if its concentration is increased to P2, so if we match these points, then we will get a graph like that. That portion indicating that the concentration of product become constant after some time, because either reactant is finished or reaction reach at equilibrium. So how can we calculate average rate here? So average rate means change in the concentration of product divided by change in time. So that will be equal to P2 minus P1 upon T2 minus T1. Negative sign to the rate of reaction with respect to concentration of reactant in duration of time of reaction. Concentration of reactant decrease, concentration of reactant increase, product increase, reactant. What will be our answer is concentration of reactant decrease. The rate of reaction problem. Question: for the reaction, reactant gets converted into product. The concentration of a reactant change from 0.03 mole to 0.02 mole in 25 minutes. Calculate the average rate of reaction units of time both in minute as well as second. So average rate we can calculate like which data we have given, that is the data is concentration of reactant. That's why minus delta R upon delta T. So your answer will be minus 0.02 minus 0.03 divided by 25 minutes. Answer will be 4 into 10 raised to minus 4 mole per liter per minute. That will be in minute. If we want to convert it into second, then we have to convert this minute into second by multiplying by 60. So the answer will be 0.01 divided by 25 into 60. So that will be equal to 6.67 into 10 raised to minus 6 mole per liter per second. Next question is, for a reaction C4H9Cl plus H2O is equal to C4H9OH plus HCl. For the concentration of C4H9Cl butyl chloride at different times, given as follows. So that is given. So we have to find out for the reaction C4H9Cl H2O C4H9OH, calculate the average rate of reaction during the first interval. During the first interval, when C4H9Cl changes from 0.100 molar to 0.905 molar. So, and second interval when concentration is decreasing 0.9052. So answer will be average rate of reaction is equal to decrease in the concentration of reactant divided by decrease in time. So from the data which we have observed in the table in last slides, we put the value. First interval means change in the concentration of butyl chloride divided by change in time. So 0.0905 molar and 0.100 molar upon 50 minus 0 second. From where we are getting this data? This data is we are getting from the table we have observed in our last slide. So answer is like that, 1.9 into 10 raised to minus 4 mole per liter per second. Second interval when C4H9Cl changes from 0.0905 to 0.0820. So again we have to put the data from the table in last slide, and our answer will be 1.7 into 10 raised to power minus. Now next question is, from the concentration of C4H9Cl at different time given below, determine the instantaneous rate of reaction at 600 second. So again we have to remember this table, we have to write down the table, and at 600 and at 600 time points, 120 time points, we have to make the instantaneous rate. So it can be determined graphically by drawing a tangent at the time t, 600 second. So first of all, we have to plot the graph according to the data which we have provided. So that we have to make a graph according to the data in table which they provided in the question. Now we get the graph like that. Got it? So at 600 second, we make a point and we can calculate the slope. We can calculate the slope. The slope is actually the instantaneous rate at 600 second. So we can calculate its slope. Its slope will be instantaneous rate of reaction. Thank you.